Good evening, Robert Scribbler. It is October 15th, 2018. Thank you for joining me for another climate change and clean energy video blog. Now, for this segment, I am going to talk about atmospheric carbon dioxide, in particular about how we are reaching the annual minimum for atmospheric carbon dioxide for 2018 as the heavily vegetated northern hemisphere, which accumulates a lot of vegetation during spring and summer and into early fall, begins to lose some of that vegetation as we get closer and closer further and further into fall and closer to winter. And this results in less atmospheric carbon drawdown by plants, and so you get a bottoming out of global atmospheric carbon dioxide during mid-October, and that is what we are seeing now. And the primary location where we see measurements for atmospheric carbon dioxide is at the Mauna Loa Observatory, and it appears that for this year the atmospheric carbon dioxide minimum as observed by the Mauna Loa Observatory will hit around 405 parts per million. We haven't seen such high concentrations of atmospheric greenhouse gases for at least the past 1.2 million years, and we are getting into a range where atmospheric carbon dioxide levels are starting to edge into the highest levels we've seen in about 10 to 15 million years. These high atmospheric carbon dioxide concentrations are fueled primarily by fossil fuel burning, and over the past few decades, we've seen about a 2 part per million increase in atmospheric carbon dioxide per year. Now, that might not sound like much, but that pace of atmospheric carbon dioxide increase is many times faster than we have ever seen reliably in the geological past. And this rapid increase in atmospheric carbon dioxide is the primary driver of the climate crisis, of the global warming crisis that we are seeing today, with atmospheric temperatures now in the range of about 1 to 1.2 degrees Celsius above middle to late 19th century averages, and edging into ranges that are starting to become more and more hazardous to a number of critical Earth systems that both human civilization and the Earth's natural environmental systems rely on. I'm just going to go ahead and show you a graph of the accumulation of atmospheric carbon dioxide since the middle 2000s, when atmospheric carbon dioxide levels ranged around 380 to 385 parts per million, but have recently built up to their present range of, well, for 2018, ranging between a peak of around 411, 412 parts per million, around 412 parts per million during April through June, and then bottoming out near 405 parts per million during the early to mid-October timeframe. Following the present rate of atmospheric carbon dioxide accumulation, we could expect atmospheric carbon dioxide levels to peak at around 414 to 415 parts per million by April, May, and June of next year. So adding yet more heat forcing into the Earth's atmosphere, which again has primarily been driven by fossil fuel burning, which will need to tamp down if we are to address the climate crisis and the atmospheric crisis of this buildup of heat-trapping gases in the Earth's atmosphere. Now, looking at the Mauna Loa Observatory, the SCRIPS data, it does look like over the recent week, atmospheric carbon dioxide levels did start to move up a little bit. And looking over the past month, we've seen atmospheric carbon dioxide levels just edging around 405 to 406 parts per million over the past month's time, with a bit of a bump up in the recent week, as I noted before, And it does look like if you look at some of these longer term graphs that we've hit bottom, or we're very close to hitting bottom for this year. Now, it is also worth noting that atmospheric carbon dioxide, though it is the primary contributor to the present crisis of heat buildup in the Earth's atmosphere, is not the only heat trapping gas that is responsible. We also look at methane and nitrous oxide and a number of other heat trapping gases which have less total radiative forcing but still have an additive effect. And if you add all of the various heat trapping gases that human emissions have pumped into the Earth's atmosphere, the total radiative forcing equivalent, or carbon dioxide equivalent forcing, right now is in the low to mid 490 part per million carbon dioxide equivalent range. And that's a very concerning range. That's, if you look at past climates, you're starting to get back into the 15 to 30 million year time frame when we last saw heat trapping gases that were so high. So just a snapshot of the present situation when it comes to atmospheric carbon dioxide, which is the primary driver of the present climate crisis, and whose increases have been driven in large part, in vast majority, by ongoing fossil fuel burning, which will need to tamp down if we're going to address the climate crisis and prevent global warming scenarios from hitting dangerous ranges or new thresholds above 1.5 degrees Celsius or 1.2 degrees Celsius or 3 degrees Celsius or more over the course of this century. And at this point, we're at a point where we're getting well above Holocene averages, and so we'll tend to see each 0.1 degrees Celsius of warming generate worsening impacts, or impacts that we are increasingly not used to. So this is a very serious event that we are witnessing, a geological event that is being caused by fossil fuel burning and fossil fuel-based carbon emissions primarily. So thank you for joining me, and I'll be chatting with you soon.